Here are two numbers, 2 and 8. Everyone knows how to average them. Add, then cut in half, 5. But there is a second average, hiding in plain sight. Multiply them instead, 16. Then ask, what number times itself gives 16? 4. Two averages. And notice, 5 beats 4. That is not luck. It is a law. And by the end of this video, you will see the entire law inside one semicircle. The first average is the arithmetic mean. Add the numbers, divide by 2. 2 plus 8 is 10. Half of 10, 5. On a number line, 5 is the balance point. It sits exactly 3 steps from 2, and 3 steps from 8. Same distance both ways. That is what adding and halving really does. It finds the middle of the walk from one number to the other. So the arithmetic mean answers a question about distance. Keep that word in mind, because the second average answers a question about growth. Suppose an investment doubles in year 1 and grows 8-fold in year 2. What is its average growth per year? It is not 5-fold. 5 times 5 would be 25-fold. But the investment actually grew 2 times 8, 16-fold. The honest average is the rate that, repeated twice, gives 16. That rate is 4. 4 times 4 is 16. This is the geometric mean. Multiply the numbers, then take the square root. And it has a picture of its own. A 2 by 8 rectangle has area 16. The square with that same area has side 4. The geometric mean of two lengths is the side of the matching square. So, 5 for adding, 4 for multiplying. Two honest averages, doing two different jobs. Now the strange part. Try any pair of positive numbers. 3 and 3. Arithmetic mean, 3. Geometric mean, 3. A tie. 4 and 16. 10 versus 8. 1 and 100. 50.5 versus 10. Every single time, the arithmetic mean wins, or at worst ties. Multiplying never beats adding. As a formula, a plus b over 2 is greater than or equal to the square root of a times b. Why should that be true for every pair of numbers, with no exceptions? You could push symbols around until it falls out. But there is a proof you can simply look at. Here is the picture. Take your two numbers, and lay them end to end on a line. 2, then 8. Together they span 10. Now treat that whole span as the diameter of a semicircle. Mark the center point, and call it O. The radius of this circle is half the diameter. Half of 2 plus 8. And half of a plus b is exactly the arithmetic mean. Every radius of this circle has length 5. The first average is now built into the picture. It is the radius. One more name, the point where 2 meets 8, the seam between the numbers, call it P. It sits 3 steps left of center. That little off-center distance is about to matter. Now stand at the seam, at P, and draw straight up, until you hit the circle. Call the top point C. How tall is that line? Here is the classic move. Join C to both ends of the diameter. A triangle drawn inside a semicircle, with the diameter as its base, always has a right angle at the top corner. That is Thales' theorem. So the height splits one big right triangle into two smaller ones. And the two smaller triangles are similar. Matching sides, 2 is to the height, as the height is to 8. Cross multiply. Height squared is 2 times 8, 16. The height is 4. In general, the height at the seam is the square root of a times b. That is the geometric mean. The second average is now in the picture too. Both averages are now in the picture. The radius is the arithmetic mean, 5. The height at the seam is the geometric mean. So compare them. Draw the radius that goes from the center straight to C. Look at the triangle this makes. From the center to P is 3. From P up to C is 4. From C back to the center is 5. 3, 4, 5. The most famous right triangle there is, hiding inside our circle. And now read it. The height is a leg of this right triangle. The radius is its hypotenuse. A leg can never beat the hypotenuse. That is the whole proof. No expanding, no rearranging. The geometric mean never beats the arithmetic mean, ever. So when do the two averages tie? Watch the seam. Keep the diameter at 10 and slide P toward the center. 3 and 7. The height rises to root 21. About 4.6. 4 and 6. Root 24. Almost 4.9. 5 and 5. The seam reaches the center, and the height becomes a full radius. 5 equals 5. The averages agree exactly when the two numbers are equal. And Pythagoras measures the gap the rest of the time. Radius squared equals height squared plus that off-center distance squared. 25 is 16 plus 9. In other words, the gap between the two averages is exactly how off-center your two numbers are. Equal numbers, no gap. Lopsided numbers, big gap. The semicircle is not finished with us. There is a third average, built for rates and speeds. Drive somewhere at 2 kilometers per hour, and drive back at 8. Your average speed is not 5. You spend far longer on the slow leg. Total distance over total time works out to 3.2. That is the harmonic mean. And it is already in the picture. From the seam, drop a perpendicular onto the radius O, C. Now look at the top piece of that radius, from C down to the foot. Its length is exactly 3.2. The harmonic mean. And that piece is a leg in yet another right triangle, whose hypotenuse is the height, 4. Leg, hypotenuse. So the harmonic mean can never beat the geometric mean. One more average, from the other direction. When statisticians measure typical size, they square the numbers first, average the squares, then take the square root. The root means square, also called the quadratic mean. For 2 and 8, the squares are 4 and 64. Their average is 34. So this mean is root 34. About 5.8. Where is that in the picture? Go from the seam to the very top of the arc. Call the top D. That chord runs 3 sideways and climbs a full radius, 5. So its length is the square root of 9 plus 25. Root 34. Exactly the quadratic mean. And this time the radius is the leg, and our new mean is the hypotenuse. So the quadratic mean never drops below the arithmetic mean. Step back and look at what one semicircle is holding. 4 averages of the same two numbers. The harmonic mean, 3.2. The geometric mean, 4. The arithmetic mean, 5. The quadratic mean, root 34, about 5.8. And they arrive already sorted. Each step in the chain is one right triangle, read as leg versus hypotenuse. Slide the seam to the center, and all 4 collapse onto a single radius. Equal numbers make every average the same. One picture. One ordering. One reason. So what is the inequality for? Here is the classic. You have 20 meters of fence, and you want the biggest possible rectangular garden. Sides A and B. The perimeter is fixed, so A plus B is fixed at 10. Try a few. 1 by 9, area 9. 2 by 8, 16. 3 by 7, 21. 4 by 6, 24. 5 by 5, 25. The square wins. Why? Square both sides of our inequality. The area, A, times B, is at most the arithmetic mean squared. And A plus B is fixed at 10, so that bound is 25. The only way to reach it is A equals B. Best rectangle, the square. No calculus anywhere. A fixed sum puts a hard ceiling on a product, and you touch the ceiling only at dead even. One semicircle, then. Lay 2 numbers end to end, and close the arc over them. The radius is how you average by adding. The height at the seam is how you average by multiplying. The foot of one little perpendicular gives the average for speeds. The chord to the top gives the average of the squares. 4 means, always in the same order, all for one reason. In a right triangle, the hypotenuse always wins. And when the two numbers are equal, everything collapses onto the radius, and all 4 averages agree. Equality is symmetry. If you like one picture doing the work of 4 theorems, subscribe. There are more where this came from.